Another example of finding all the roots from a quartic polynomial, we can find the possible rational roots, plus or minus 5, plus or minus 1, plus or minus 5/7, and plus or minus 1/7. Looking at the coefficients by Descartes' rule of signs, because they're all positive, I know that there are no positive roots. So we can erase all of the possible positive roots and just say, okay, we're left with negative possibilities. Now, which one do we want to try? I'm going to try -1. If you tried something else, it might work, it might not. So let's try this. 7, -7, 43, -43, 41, -41, 5. Ooh, yay, it worked. All right. Let's see, what should we try here? So they're all positive coefficients, so there's still 0 positive roots. It could be -1 again. May as well try it. So 7, -7, 36, -36, 5, -5. Oh, hey, that worked. So we have x minus 1 as another root. Oh, well, wait a second. We don't have to keep doing this. Once we've gotten it down to be quadratic, then we can just factor normally. So 7x squared plus 36x plus 5, we can factor as 7x squared plus 35x plus x plus 5. So 7x plus 1 times x plus 5. And then we can multiply by the x minus 1 factor that we got twice. So what are our roots? We have 1 with a multiplicity of 2. We have -1/7, and we have -5. So the key thing here is realizing that if you get these rational root possibilities, figure out where to start, but based on Descartes' rules of signs. So seeing that they're all positive coefficients tells you there aren't any positive roots because there aren't any sign changes, which leads you to starting with negative numbers instead of positive numbers. Oh, I'm sorry, this should be a -1. Also, if you get to a problem like this one, where you see, okay, when we tried 1, we got all positive coefficients, it was too big. So that's where the upper and lower bounds come in.